not watching live, again, welcome to the ITI Showcase Webinar Series. This is Zach Parnell, Vice President of ITI. We're excited to go over this session today on 10 points of lift plan development. We have Mike Parnell, our President and CEO, is speaking, and I also have Jonah Hobson, our Marketing Manager, here today. But if you're not familiar with the webinars, I do want to make sure you're totally aware of how we do these things and who ITI is. So in short, we're really just an education provider. We don't do anything but train and consult, really. There's familiar names and customers in the room right now listening, and we appreciate your attendance. And we're really chosen by most of the Fortune 1000, Fortune 500 companies to help them increase and enhance their lifting operations and the skills of their employees. If you're new to the webinar series too, if it's your first time, I'd really encourage you. What we're doing is recording the series, and you can go back and view any of these webinars, the past presentations. I think we've been doing this for over a year now, once a month. So there's just an incredible amount of recordings on our website, as well as the PowerPoint presentation files, which you can download and use as obviously internal just reference. Today, like we said, we're going over lift plan development. We also have a paid webinar training course series where we actually pull out some of our course curriculum to teach via webinar. Most of our courses are taught at training centers around North America or at our customer locations, but these webinars are about 2.5 hours. We have one next Friday, I believe, on advanced rigging, so I'd really encourage you guys to check that out and see if it applies to you. But we do offer ITI CEUs for that, and it's a really good, we limit it to about 10 to 15 people per instructor, so it's a really good session there. If you're not familiar with Mike, I want to introduce him really quick. He's our President, CEO, and more appropriately, he's our Technical Director. He creates all of our curriculum. He's got over 30 years of experience in the industry, and he currently sits as the Vice Chairman of the ASME B30 main committee. And I'm sure he's going to touch on ASME P30 a little bit during this presentation. It's a new standard. I think it'll be rolling out. He can comment on it later, either early next year, I believe, but it's the lift planning standard. So as he goes over this lift plan, I'm going to change over him as a presenter right now, and I think we're going to start this with a poll question, but I'm excited for him to present on this, as it's obviously a very hot topic. But go ahead, Mike, take it away.
All right, very good. Well, it's so nice to have everybody with us. We look forward to a good this will be fairly high impact and quick webinar today, and then we have a number of others coming up in the future on advanced rigging. I think there'll be a absolute blast to get involved in problem solving and some workshop activities. Did you want to do a poll question now, Zach? Is that?
Yep, we can launch the first poll. I think you want to do this. Jonah helped you set this up, but the question asks, what percentage of crane lifts at your facility require written lift plans? So if you can take a minute here to just click on one of the selections there. I think this was a good kickoff question to get the presentation started, so Mike knows kind of the understanding of what you all deal with at your locations. So we have about 50% voted, but again, Mike, I'm sure you'll have some reasoning behind this, but it looks like, again, we have about 3/4 voted. And again, what percentage of crane lifts at your facility require written lift plans? So I'll leave it open for another 5 seconds or so. I feel like an auctioneer a little bit, actually, asking for votes and talking while the votes are coming in. But I'll close it now in about 3 seconds. We got about 80% of the votes. So 1, 2, 3. Thank you guys for your votes. And Mike, I know you can't see this, but the poll results show about 35% of folks require, well, I'm sorry, what percentage of crane lifts? 76 to 100% of the lifts. 35% of the attendees said that those require lift plans. And you might be able to help us all understand where we're going with this one. But on the other side, only 0 to 25% of lifts require lift plans. So, and that's a 30% vote. So I'll let you, I'm going to hide the poll results now, and you can go back to the presentation here.
Okay. All right. Excellent. Well, that's very good. That's interesting information that we are able to gather there. What we see in typical industrial environments, and I'll say, well, let's start with industrial. Typically, we might see 85% of our clients in refineries, paper mills, mines, obviously shipyards and things like that. Their 85% are standard lifts, and then about 15% or so are critical lifts. And it gets down to, these are typically the documented grouping, and these are non-documented. So it gives you an idea that of our customer or client base that we work with, as you saw in the roll-in, folks that typically get involved with having us participate in their year-round program. It's not a huge group in the industrial market that might be involved in documented lift planning, but then you go over into just as a for instance, for construction. Here's kind of the opposite spectrum. It gets down to somewhere in the 90. I'm estimating here 95% would be standard lifts, non-documented, and then only about 5% would be, we call them in the critical lift category, and they would be documented. So it's a much smaller group in the construction field, but as a general rule, you get down to we're going to say nuclear, and then sometimes in aerospace, and other critical environments, testing environments like Sandia National Labs or Los Alamos National Labs. Their numbers are going to be completely reversed, and that documented lift planning will, this non-documented will be down in the 10% range, non-documented, and in the 90% range for the documented. And part of this is really to get down to the idea that there are categories, and we've heard on other presentations the reasons that we have or that might trigger documented lift planning, and it's the value of the load, the replacement time, the sensitivity of the equipment, the overall impact to the operations if the load is dropped, and so on. So those are all things that help drive that documented effort. And what we would encourage, at least even a simple lift plan for standard lifting activities as well, and it can be verbal or it could be written. So it's a really good, interesting cross perspective on what can happen and what is happening out in the marketplace. The presentation today really is, these are the 10 basic points that should be considered or developed in the lift plan that you've got going, whether it is a standard or critical lift, and at least verbally communicated. If not, then also documented. So let's go forward. In the first item here, of course, is the load, and the load is really number one, and it gets down to obviously the weight, center of gravity, and its dimensions, and what is the source for that piece of information. Are there anything in the load that can shift or move that would cause a relocation of the center of gravity during the lifting process? That can be a huge issue. Running water, running fluid, oils, or items that move while they're being handled. and then verifying the lift points. This is something that gets beyond, sometimes a bit beyond the riggers base, but gets into potentially some more engineering base, is evaluate the attachment points. Are they suitable for the load handling? We noted yesterday we were in our own yard out here, and we have a, I'm going to call it a two-piece hoist, and it's got the upper works, and the drum is inside. There's a motor and gearbox, and it's basically a large overhead hoist, and then it's actually got a mounted track trolley system that's below it, and it's got the truck end wheels and so on, and so we've got all the components are there, and then looking at it, we have connection points. There are bolts right here that connect the upper, this is the upper portion, and the lower running trolley frame. So these upper bolts right here, I think the big question, because there are lifting points, there are gussets right here that are suitable really only for the upper portion. And there are brackets and framework down below. And so a key question is, if somebody decided to tie into the upper, they'd want to make sure and double check, are the upper connections that we've identified here for lift points, the load path, travel path, the load and tension passes, obviously it's down through the sling shackles, the gusset plates, connection points, and then through each bolt that are designated to lift the lower frame. And after reviewing it, we opted to say do not lift, and what we're now doing is, and we've never lifted this load before, but we took a look at it first off and said, gee, these bolts right here are only designed for securement. They're not designed for literally lifting the entire lower section. So before this thing is handled, we would have to, we're opting, obviously, we're going to take away all those upper slings, and we would need to be able to connect to this lower framework to make this pick and to be able to move this item. We've got to make sure that the connection points, as noted right here, the connection points are suitable for handling, and as we travel and pass down through the load path, top sections bolted to intermediate, bolted to lower piece, and if we're picking from the top section, were those pick points only designed for that upper section, or were they designed for the entire package? And that's a very critical question. Those bolts may be just holding down, not lifting up, and there may not be enough of them actually to lift. So look at the load's overall structure, make sure that the pick points are suitable for the entire package and that they are approved for lifting. The orientation is there, the proper direction of force is there, and so on, and they will take the anticipated load imposed by the slings based on the angle. So the load itself, what's it weigh, center of gravity, and then pick points, those are all get covered in the first question. So there's number one. Number two is the LHE, and you've heard me say before, this is really sort of new language coming out in our industry. LHE is, it can be a crane, it can be a telescopic hydraulic gantry system, it can be jacks and rollers, it can be winch and blocks, and so an LHE is really the load, what's moving the load, that's the idea. And so once we look at that, what are we going to move it with? Then we need to identify, does it have capacity within the configuration acceptable? What's the impact potentially of some dynamics? And there's going to be some natural speeds involved in hoisting and moving. Is there any load eccentricities that might impose some unusual load to the LHE? And does the LHE meet the regulatory or site requirements? There may be hoisting systems that may have no upper limits or upper anti-two-block device, and based on its configuration and its application, it may be a no-go. So it's a question: is the LHE acceptable for what it's being used for? And then obviously proper setup, erection, installation, and dismantling procedures need to be fully known to all the folks involved in the project for the setup and tear down, and of course it's leveling, ground bearing pressures, all those things, and those will be led into another point downstream. But item number 2 is the LHE is the most important part for getting that load moved. And you may have 3 options and get down to either something that's lowest cost, easiest to assemble, most common to the work site, most common to the crew. It's got to be selected properly. We don't want to just hope for the best. We've got to make sure that we've got full rated capacity based on the anticipated load movement, based on radius, if it's a mobile crane, and so on, and that's able to sustain itself in the configuration which is assembled. So number 2 is the LHE, or load handling equipment. Number 3 is the rigging. And so the method will actually drive to identifying, do we have capacity, or we rig to the center of gravity, and its installation methods, and certainly then gets down to rigging protection, sling protection. There may be temperature considerations, chemical considerations. D to D is large D versus over small d. That's diameter of object to diameter of wire rope sling or synthetic rope sling. Edges, abrasion, and then load turning. We're going to catch this load on, catch the slings on some edge. So as a rigging method, all of that's driven by the method, because method then is going to determine capacity and all the other consideration points. We've noticed I've got a number of circumstances where we have load turning going on, and unfortunately, in this, I'll just kind of sketch out quickly. We've got maybe a vessel here. It's got some trunnion pick points out here on both sides, and maybe a tailing lug up here. Unfortunately, what will happen from time to time is the sling simply will go up and around to a crane hook and basically hug the load. And as they make that arc, as we upright the load, these slings will be passing right over that load edge. So it's very important in the planning process, help keep those slings away from that edge as they slide and slice across. And a spreader bar there is an optimum tool to be implemented, to be used in the rigging assembly, and so that we're able to freely pass, we'll call it an open pass, to be able to ensure that the slings can pass without any kind of contact with that upper head end of the load. The tailing is typically not as big an issue unless we also have twin lug points here, but even at that, they'll be crowded into the load, and it's not as significant because they're not having to pass typically against a hard edge. Top tailing lugs are optimum. They're very good because they will help minimize the impact of headache balls or the tailing block, crane block, to contact the load, and that would be preferred versus slings sliding and scrubbing just simply along the load surface. So an open pass really is optimum method here, and it is a consideration during that rigging element decision on methodology. Do we have the right rigging for the right job? Are we going to be turning this load? And if so, are we going to keep the slings off the load? We, as most of you know, under previous presentations, I think we had an entire one dedicated to rigging accidents. We, in our experience, we had 87% of the sling and rigging accident and sling failures were synthetic related, and we own a lot of synthetic slings ourselves and use a ton of them in everyday work. But synthetic slings are great tools, but the biggest issue is that they're lacking protection. We're not, as an industry, we're not keeping them off the load or away from those edges that can either cut or friction burn them. So big decision there to make sure we've got protection for the slings. In some rare cases, a wire rope sling can be cut. In some cases, chain slings might be compromised to some degree, but synthetic slings really are our first focus for protection. So picking the rigging, good method, good protection, and obviously within rated capacity, huge decision, making sure that we're good to go. All right, item 4, LHE and load movement. So this gets down to the load movement and the travel path. I'm going to bring up to your for your consideration to take a look at. This is just a blow-up of a lift plan, but you'll notice in here we've got a pick point off one direction off of here, and then the load is swung around and then boomed down to another direction to a 180 position, and the radius changes. So the question gets down to what is the load movement and travel path for the load and for the LHE? Is there any opportunity? Are we free from inadvertent contact with anything else? Again, dynamics may be a concern or question. You might be taking a load off a barge that's floating. So we have dynamic rise and lowering based on water tides and or wave action. Could be on a barge crane. Also, personnel positions during the LHE and load movement. Where are the people? Where are the spotters, signalers, tagline folks? Is a blocking ready, and who's the connecting crew? Because if we're going to move a load from point A, we're going to swing it around and then boom down and land it. We need to know where the folks are, where can they have optimum visual. Can the signaler lead the load and stay out in front? The tagline person may be behind. And then we have maybe safety spotters around to help control that work area, and that's all done at final assignment during personnel assignments and locations. So everybody's got a job, and it's really, we don't want to be running the load over people or into obstructions or getting people aced out where they can't see what they're assigned to see during the load handling activity. So where's the LHE got to go and where's the load got to go? Those are certainly big issues, and that's in item 4. Item 5 is personnel training and qualification. Do we have the right folks doing the right things? So you'll notice that OSHA and a number of Canadian requirements talk about competent, and or there may be terms qualified person and or qualified lift director, qualified rigger, qualified signal person, and or designated person. So is their training up to snuff for what they're supposed to be doing, and does that lead them to being qualified to accomplish the task assigned? And this is just a short list. It's not a huge list of all parties, but it gives us a good idea of what we should be considering, who we should be considering, and what their assignments and tasks are. Even a site safety officer, I know it sounds a little crazy, but site safety officer, as you'll see at the very end of this, that emergency action plans need to be reviewed, and travel of pedestrians, travel of vehicles, all the items that might be involved in the plant for small shutdown sections or areas that are purged to help ensure that we don't have volatile product going through lines and things. So, but the people side is definitely an issue, and we want to make sure that we've got the right folks qualified doing the right things. Item 6, what about this site? And this is, again, going very quickly, scope of work. What do I have to do? And it's, in effect, if the main task is installation of an item, and it's from and to, and what's in between. So what's my scope of work that is understood by the lift director, the riggers, and all the other personnel associated with it? Do I have access, travel path for my LHE egress for LHE and load? Foundation is on the site is a huge issue. Compaction test, geotechs may help with that. Soils analysis, structures and vaults and voids and backfills. An easy thing to do, I know we've probably all heard of cranes tipping over before they even had a load on, sometimes just because of poor foundation, even just in accessing the site intended. And then the load landing point. We've had a couple of incidents where the blocking started out fine, and it was all of a sudden the load starting to tip over because we're losing our soil and ground-based compaction for the object or for the item that we're setting. So if we don't have good foundations underneath, we can actually sync that blocking set in and literally tumble the load over. And I know that's after the whole load activity is completed, but load landing point is very important for, do we have a stable place to put this where for its intended time, it's going to be suitable and stationary, and it's going to be as we intended it. That's the whole deal, is the site prepped and ready to accept this. And it goes well beyond certainly the LHE foundation. It gets into even just the load landing point. So don't forget that. It's an important part of making sure that we've carried off the entire plan. We've achieved the scope of work is to pick it from and land it to, and when we land it, it's stabilized. So that's our job. That's our, for a crane and rigging crew or load handling crew, that's our task, is to make darn sure that we've got good solid foundation and we don't end up with oopsie crap, say all of a sudden we got the load over. Communication is the next item, and we are suitable communications. We all know that hand and voice are hand signals typical, voice signals continuous communication. There may be other type signals, horns, lights, bells, and we certainly have different operating activities that still use bells and whistles for signaling. One of our guys just got back from Panama, and they're using whistles as their communication system in laydown areas and shop areas, and making sure that they're clear, concise, and everybody's on the same game plan. Main thing is that it is by voice communication or by hand signals are the most common, that they're clear, and if not understood, then we need to stop. And that's the whole enchilada right there. Need to stop, and we need to fix it and make sure that it's fully understood by all parties, and then before we resume. So once an operator, if he doesn't understand, gets a breakup on a radio, doesn't see the hand signal properly, or can't see it, he just needs to come to a stop, an easy stop, and then that signaler is going to find out, hey, why aren't you moving? Get communications open back up, reset the game plan. Lift director probably would be involved if it's a critical lift, but otherwise the rigger or signal person that's giving signals will take care of that. But the key thing is stop. Let's not guess. Let's not hope for the best. Let's not sort of, the old joke, hold my beer and watch this. I don't think we want to do that. We want to make darn sure that we've got it controlled and everybody's doing, and the whole action and activity is unfolding as intended. And once we, and there should be a backup plan for communication. So making sure that we've got either backup radios or batteries if we're using those systems. Certainly we could, and some folks do even, it's possible to resort to cell phones if they have communication ability. It has been done, and it's not illegal to use, but it does take hands to do that unless you've got hands-free opportunities. So that's some of you may think, well, that's just a stretch. Well, you know what? If you've got a blind pick and other things, sometimes cell phones may be the second or the intended backup plan, and that may be a planned event by the lift director. So not beyond reason, but it certainly would be hands-free would be the proper approach there. Let's take a look at number 8. Site control, and this is where that safety director and safety supervisor we talked about, and this would be site supervisor would be assisting, and or the safety folks, or some combination thereof. And vehicular traffic around our lifting activity, potential interference from ongoing plant or site operations, and it may require barricading, guards, and or some other physical measure that would restrict interference. So site control is important. We want to definitely make sure we don't have forklifts or trucks rolling into an area that they simply didn't understand there was a lift going on or a large load being passed. We need to make sure that they're dialed up, and or we simply set barricades. And we may have personnel, safety spotters, and other designated persons helping redirect folks as necessary. Okay, number 8, we're about down to it, and number 9 here, contingency plans, and these all get down to response teams. Identify the types of hazards, what's recommended action, and contact and communication. You can only control so much, and I think this is an area where you can get really bogged down. I know Intel used to have commercials out there that they ask this big question, what if, and just always looking and exploring the possibilities. But by the same token, you handle what is predictable, and then be ready. But you can't you can't envision a meteorite hitting the job site, and all of a sudden now we have a bigger problem, certainly, or a tsunami maybe screaming across and rushing up onto 400-foot elevation. I mean, at some point, or an earthquake, at some point you just have to go forward, and you've mitigated all those things that you can deal with, which gets down to things like weather, visibility, machine conditions, personnel assignments, personnel locations, all these things that you can have some reaction to, because you can deal with them, you see them, that you know that they're there, and you have technology that's helping inform you. We have a big weather front moving in. We're going to be picking up to 50-mile-an-hour winds this afternoon. Well, our technology is helping us, and that's helping solve and resolve some of these things related to contingency plans. So we simply won't even start a large lift if we already know we've got weather moving in, and or a large fog bank rolling in, visibility 0, and your lift plan requires a certain degree of visibility to be able to achieve lifts. In certain environments, I know we've got cloud action, and visibility always is an issue. Take San Francisco and some of those areas that get fog all the time, and numerous pictures have been around on the internet that you see a tower crane well up above the cloud line and fog line, and he cannot see anything below him. So, but they still have to get work done. So they just work on contingency plans. They work on radios, and the operator he'll have potentially a rope footage counter inside the crane with him, so that he can tell how far the block is coming down through, and he's got an estimation. He's at 250 feet, and he knows he'll start to slow down also with radio communications on a continuous basis. So, but there are things that are out of our control, and do the best you can, but really we can only manage the things that are really reasonable to be in front of us and deal with them. So I can tell you, and we can all kind of sit together and hold hands and say, you know, we can't cover everything, and you're absolutely right. But to those things that can be evident, can be realistic, then let's deal with an answer for those and move forward. And the last thing here is an emergency action plan. This is not generally, and I'll just state this, not generally created by the LHE crew. This is generally provided by site safety and or their designees, and these are the folks kind of driving that bus. And the site plan will be have a emergency action plan, pre-identified responders, and then just simply ensure that the rigging team is informed and they understand those responses. It could be gas leaks, chemical spills, chemical leaks, all kinds of things. And so they just need to know, what do we do if? And so those things are predetermined during the PreLift meeting and discussed, and then folks have some privy or some inside information as to what would we do here given these circumstances or conditions. So it is typically implemented and managed by the site safety folks, and they should be an active, integral part of lifting activities on your site. All right, Zach, let's see. I'm going to do this, and then we'll be ready for a poll. The PreLift meeting, and this was this can be for standard or critical lifts, but this gets into, obviously, it's a step-by-step process. One is review the activity at hand. Obviously, that's a bit of a review of the scope of work. What are the sequence of events that we're going to be incurring? What are the folks supposed to be doing? Signalers, spotters, tagline persons, traffic control persons, and so on and so forth, riggers, operators, and so on, rigging the load, unrigging the load, and then entertain questions and find solutions for them. That's typically the lift director's job. And then review, and then this may or may not happen. Sign off in some cases is a requirement, say in a number of nuclear facilities, or maybe sign-offs. Construction, industrial may not have any sign-off for that except a document signed or managed by the lift director and lift planner. So the pre-lift meeting for standard lifts could be 5 minutes, could be 3 minutes. For critical lifts, it could be 2 days or more. The pre-lift meeting is a discussion and dealing with each one of these sequence, or each one of the items listed here, and then some as they arise. This questions and solutions could lead you to a whole nother series of 2 or 3 hours of other issues that may arise that the lift planner has not been able to track down or to solve yet. So you may have 2 or 3 pre-lift meetings even within a short series of a couple of days before a large lift, as you resolve these items that are connected to some of the questions and finding some of those solutions. Zach, I think we're going to do a couple of back-to-back polls here, I believe.
Yep. We'll launch the first one right now regarding pre-lift meetings. Does your company conduct pre-lift meetings for standard lifts? So this is obviously not there's tons of lifts done every day and every week, so it's not a numbers thing, but this is more in general. The answers might be never to always. So never, sometimes, often, always. Looks like we got about 60% of the votes coming in. Everyone stay tuned because we have another poll right after this one, but we'll go ahead and close it in about 3 seconds. And it looks like the results will show sometimes. I mean, 43% of the folks said sometimes during standard lifts. Never was 13%, often 23%, and always 20%. So the next question, you guys, is regarding critical lifts, and the same sort of question. So does your company or organization conduct pre-lift meetings for critical lifts? So please go ahead and give us your thoughts on that. So as opposed to standard lifts, as Mike's gone over, let's chat really quickly about critical lifts. And already overwhelmingly, it looks like most people have written down often and always. We'll leave the poll here for another 3 seconds or so. And yeah, we have most of the votes in now. So I think polls will show about 75% of the people said always, 21% said often, and sometimes about 4%, and 0% said never. So, Mike, those are results. It's pretty indicative of your findings as well with the 85-15 rule, I think, and then right. pre-lift meetings go along with critical lifts, just about, right? So. Right. Yep, and they may be fairly short in their application. It may be a production facility that's got some very expensive, high-dollar items, and all the rigging's been pre-inspected. And the pre-lift meeting may be 5 to 10 minutes, maybe 30 minutes, because you may have a new cast of characters, new players, new operator, new rigger, new lift director. So everyone has to get dialed in. And but at the end of the day, it may be something considered to be a production lift, meaning it's a repetitive type lift, those still critical. And those decisions for what's covered should come right off your lift plan and then go right down through the sequence of events and the participants' assignments. So thanks, Zach, very much. Let's take a look at certainly the next part is to execute in this case, the critical lift, if that would be our case. We're going to assume this one's critical lift. And in the doing of that, of course,
The LHE is inspected, the load's inspected, so is the rigging, the people are ready, and the site's ready. So we do it. So at some point, just like Nike says, just do it. Hope we don't get into some infringement there. But we got to get down to getting the load moved, getting it handled, everything's working and working appropriately. And once that's done, initiate the lift and stop if absolutely necessary, adjust according to contingency or acceptable methods. And if it's impossible to proceed, all stops, secure the LHE and the load. This might be with a huge storm moving in. Some things happen and some things you've got to have a response to it and do it intelligently and smart and make sure everybody's okay, but also the load's good and the LHE's good. So the lift is performed, and then we do a post-lift review. And this is something I really encourage all of our listeners to get involved in. Hey, after you're done, don't just go tuck away the rigging and fold the crane up. Actually review, for a critical lift, actually review the lift, re-inspect, and update the lift plan. You may have another lift to make, just like the one that was prepared or performed, and we want to make sure that we've got that. And it's really for the benefit of the old team, but also for the new team. And it is a huge time saver if those things will be done in a repetitive nature. And we need to do these 16 load moves. It might be moving bridge trusses or other items that are going to be really close, if not exact, as the crawler crane moves along, and a constant radius of 60 feet for landing. And the pad's prepared, everything's fine. So there's a repetitive lift activity. So that enhancing that for those duplication type lifts is really valuable. So it cuts down, if nothing else changes, cuts down on a lot of revisiting and a lot of reinventing the wheel, which is not always a very popular and fun thing to do. So taking a look at the lift plan, is it still workable, still doable? Can we use it? Yes, and we go forward. All right, I'm going to take a look. I tossed up on the screen a minute ago. These are 4 pages, and I've got them in miniature view here. I'm going to bring them up to show you what we've got. So you'll notice that we've got a lift data page, and I'll blow this up in just a minute. We've got a lift data page, a travel path and personnel placement page, and then we've got a load schematic, rigging schematic, and then we've got personnel. So I'm going to take you down through this very quickly, just take about 3 or 4 minutes, and let me bring these up so that they're a little more highlighted here. And in this particular, let me get you the first page here. This is really the lift data page. And so in our discussions today, we identified the load as being an item of primary concern, and it was our number 1 item. And so this entire bank right here is item number 1. Item number 2 for this particular plan is denoted as the crane. And so all the data is collected there. All those consideration points are highlighted and noted. Item number 3, right down below, that we covered today in our presentation, is the rigging. And this rigging then transfers over to the rigging data and how it's assembled and the items. So this carries over to its own unique page, and it highlights the rigging consideration points, the rigging method, the capacity, which are noted back on the front page. And this helps the crew understand how we're going to rig this up, what's the load handling method, and we'll put the tagline on, and we'll get everything moving in the right direction. So the rigging actually enjoys its own page over on another section. Number 4 is, let me get my document here. So number 4 is right here, and it's about the load travel path and the personnel, the load travel path and personnel. So note that we've got the location of the crane setup, it's going to basically be stationary. It's going to pick off, let's say in this north direction, swing 180 degrees to the south direction, and then boom down and place the load at about 60 feet, 65-foot radius. So we've got a general idea where we're going to be going with the load, and then certainly we've also got highlighted the tagline person there. Here's our signaler. The operator is right there, and we've got a spotter right down here. Dan Danford is the spotter at the set-down point. So we're handling both the load and LHE travel path as applicable, and also personnel assignments are covered there. And personnel assignments are also covered right back here on the last page. And I'm going to put a number 5 back here. That was our 5th one. And this was a lift plan that was made for a particular lift in Texas. And so we have these 4 folks in active roles: operator, rigger, signaler, lift director, and then site supervisor. And all the way down through, down on the right side, I'll blow this up a little bit. You can see that we've got Kim Evans right here, Dan Danford there as responsible. Ensure weather, wind, and ground conditions are within tolerance. Evans and Danford here, ensure area is barricaded and traffic properly routed. Bill Humphreys and Scott Lucas, ensure crane and rigging is inspected and placed properly, correct configuration. So we've got, so on the follow-on, we've got all the sequence of events on command from the lift director. Operations to go forward. Signalers to hoist the load 1 foot and hold. Stop 2 minutes. That's to confirm the brake. Signaler to hoist and 8 feet and stop. Signaler to swing to the operator's right, 180 degrees. So everything's detailed down as to who's doing what, where's the load going, and this is all discussed during the pre-lift session. So it is, it's helpful because this is where your questions and solutions come up. Have we thought of everything? Do we have the obstructions? Do we have barricading? Do we have overhead power lines? All those things start to come out in this review of the sequence of events. And then I'll go back into page 1 here, and we have item 6, site considerations and foundation. We have foundation right here, power line issues, obstructions involved. Do we have to travel with the load, work clearance and traffic patterns, and so on. Then let's come down a little further, and down on this considerations on our data page, we have personnel and task and assignments and safety considerations. So all the folks here, those are initials based on who's checking or who's confirmed that those items are in place. And then right down below, we finished up with our contingency plan. Here's number 9. And contingency plan can set load at halfway point, no obstructions. We could set it right back down on the ground. We can swing and set it halfway to the swing arc, full swing arc, and set down. The only issue would be setting it up on its upper landing, and that might be the issue. But yes, we can set it down in its full arc. There are no obstructions. And item 10, as we discussed in the presentation, EAP is Emergency Action Plan and reviewed by Site Safety Director, and that's been covered. So this entire 4-page document actually covers all 10 points that we discussed today. And just for anyone that would like to get this electronic version, if you don't already have something, hey, as a courtesy from ITI, I would love for you to have it. Why don't you contact Jonah at ITI.com and ask for you can ask for the mobile crane critical lift plan. So if you'd like to get one of those, it's just an Excel document. It is copyrighted, but what we'll let you do is to use it in-house, and you can't reproduce or sorry, you can't sell it, but you could use it in-house. If that helps you out, consider it a gift from us to you, and you can get that critical lift plan on Excel format. And you may have lots and lots of existing documents in-house that you already use, but at least it's a good 4-page document to which to build. As you noted during what I have been able to show you is all of these items are handwritten in longhand form. Certainly a lot of folks will be able to type in all the data, type in all the information as appropriate. You can roll in pictures as we've done here. There's a ton of things you can do with it, and it's easy to use. And then certainly get back to, and this is again, we wrote it in for this lift plan, but it can be typed in quickly. But this was able to get a lift knocked out fairly quickly but thoroughly. And so writing it by hand is not against the law. I mean, it's fine, and it's at least it can be communicated. And so it's easy to share with the team. And everybody's got a view and an understanding of what's going to happen and how we're going to get there. So let's see if we have any questions and anything I can help with. This is all part of the P30 core base of material that will be hopefully printed by Christmas and or before. And the P30 document, as Zach had mentioned, these are really these are not brand new by anybody's stretch, but the P30 ASME P30 document is it will be finalized. We're hoping it's out for a final public review vote right now, and these are at least the 10 steps that certainly are contained within the P30. They're really, again, by a consensus group of 25 folks that have helped assemble this. Almost everybody brought the same list of 10 points, 10 major items that they thought should be considered, and those are the things that I presented to you today, and they will be highlighted within the ASME P30 lift planning document. Zach, are there any questions or anything that anybody's got in that we can help with? Otherwise, we'll be signing off pretty soon.
Yeah, I didn't see any questions come through yet. If anybody has any specific questions they'd like answered, you can write them in the questions pane. I think you covered everything really well. The one question I would have, maybe put myself in the audience, is how much direction does P30 give to use these 10 steps? Meaning, is it it's the best practice approach, or like what's employers supposed to do with the 10 steps in the standard?
Right, excellent question. And what this will be, it'll really, there is a, the ASME P30, as with other documents, as we all know, they're voluntary. Quite often, OSHA and Canadian groups will reference them, directly reference them, and so when they are referenced by OSHA or OH&S in Canadian province, then they become law. So they're intended, or they're published as a voluntary first, and then from time to time, these two groups that are legislated will then refer to them, and then they become a part of the law. So this is written as a load handling guideline. There are actually very few shoulds, or shalls, I mean, in it, but there are a lot of shoulds, and it is regarded as what we will call it as a best practice. And I think it's a little too early to tell whether this will be referenced, but I believe it will eventually will be by OSHA and OH&S. The ASME groups are volunteers, and they're not part of the legislative activity. So, but once they create a document, quite often they do get adopted into a governmental oversight group's regulations. So at the moment, their best practice, will they be eventually regarded as a legislated item? I'm going to at least say 50-50. We probably have a dozen different documents from ASME that are being referenced by OSHA and OH&S in Canada. So right now, there's a best practice and probably a good chance that it will be eventually referenced as legislated requirements. Hope that answers your question.
Yeah, very good. And what I'd like to just point out to everybody really quick, I'm showing my screen now. is that on our website you can learn a whole lot about the courses we conduct around this subject. So, and under the training tab, it's our whole curriculum under there, but under lift planning, we do have a critical lift planning course and a lift director course, and those are really in our lift planning school, if you will. So it gets a lot deeper into the, for instance, the mobile crane lift plan Excel document Mike was talking about. I encourage you all to check out those open enrollment dates if you're interested in attending, or we can also conduct the courses at your facilities. So I want to point that out after you mentioned that, because we're already training it. It's not, we train it for skills building, and employers pay us to do that every day to increase the skills of their employees. But meaning that it's not yet legislated, but it still is highly, highly demanded. And who knows, like you said, I'm sure it'll be adopted fairly quickly throughout North America. On that note, one question did come in, Mike. It basically asks, when do you engage in an independent reviewer or a monitoring expert with a lift plan, if it's critical? Do you always do that, or when would be the appropriate time to do that?
You know, that's a great question, Zach. We'll just keep your screen up for a minute if you'd like, or I can take, but it is, you know, I'm going to say it's pretty rare. This may kind of come as a surprise, but question, you know, I think I understand the question. When do you use a third party? I mean, would be the typical phrase. I'm guessing. So, but it, you know, really, what happens is a general contractor, the project owner, is overseeing the entire activity. They may likely employ a general contractor, and that general contractor then may use an LHE specialist. And those might be folks that are part of the SCNRA, Specialized Carrier and Rigging Association. They may bring in gold hopper trailers, or they may use gantry systems, the two-crane pick, all kinds of things. But there would not be a requirement generally by the project owner to require a third party, and probably not by the general contractor. So either project owner or general contractor would not require it. But LHE specialist, whoever is going to be the load handling contractor to get the load installed, so they'd roll it into the project, place it, set it. But I'm going to suggest to you, probably only about 5% of the time will they use a third party, and at this level for these folks, for the specialist to use, and it'd probably be equipment specialist. And that may be that these folks that they bring a third party that's really they may specialize in the equipment usage, and that it's being leased or rented, and they may bring a specialist to help assist with that. On the other side, I have seen about, I'm going to say about 10% of the time, depending on the complexity of the activity and ongoing work, will a general contractor bring in a third party to help defend what's going on the site. And it's not a very comfortable situation. The general contractor may be a good, you know, somebody sent out a bid package, and XYZ has received that package, and for whatever reason the general contractor says, I want to have a separate set of eyes on this, and this will be our representative to attend these lift planning sessions and lift planning activity, pre-lift meetings, and so on, and he will be our eyeballs who knows all about this type of load handling activity. And if he's got an issue or a question, he needs to be responded to as if you're responding directly to us as a general contractor and respond in kind. It's not done very much. but it can be done, and I know it is in a few cases. But and we even served in that role with a power company for a transformer installation. So it's just a specialist that really is dialed in, but they're there to. It's almost a liability position that third-party person is brought in, and that it's rare, but it can happen. So third parties really are. It's rare because this contractor actually, they sign on with hook insurance and all kinds of things to take on that project, and there's generally very few other people goofing around inside of their lifting activity and planning work. So it has to be for a special purpose, and it may be that the general contractor says, well, for liability purposes, we're going to bring in Bill Smith or whoever, and he's going to be our representative during all planning and execution activities. And it just may be for insurance purposes. So not very common. It's, right out of the box, it's not very common. Hope that helps you.
Yeah, certainly. And another question came in on that. If there's no contractor involved, meaning it's just an in-house critical lift plan, that might be, is that when more third parties, it's actually just a outside vendor would come in as a subject matter expert then, correct?
That's correct. That's absolutely, and that's, so if it's an in-house project team and it's all within that corporation, very definitely, and if it's in this, what we're going to call the critical lift plan category, I'm going to suggest to you that it wouldn't be anything unusual to get 20 to 40% of the time would they bring in a specialist to help resolve issues related to that load handling. That'd be very common. And so that's where they may lease that equipment. Their folks are their maintenance and production folks. They have most of the knowledge that may be a little foreign with the equipment they're using. But in that case, it would be a much bigger percentage that they'd bring in a third party to help assist in those activities. So I'd certainly agree with that.
Sure. Well, and I wanted to point out Jim Worrell, thanks for being online, Jim. You had a good comment here as well. He's done a lot of lift plan reviews. He mentions a comment on this subject. Reviewing the third-party reviews that I have completed, I was lucky in that most were well-developed plans by reputable subcontractors. However, in nearly all cases, I have uncovered some small issues that would probably not be a cause of an accident, but would be, in the case of an accident and lawsuit, be a problem. So he's done a lot of oversight, and it's always great to have another set of eyes in there, but I think politically, Mike, you're talking about the issues that can arise having a third party in there, especially when you've already hired a contractor, right?
Right, yes. And Jim's absolutely correct. And the thing is, we'll all focus on 90% of the things that we've grown up with, and to have a third party come in from time to time is very helpful, and because they will be looking at quite often at that other 10% of things that these have bit them in the rear end before, or in other site locations that they worked in, and it's very helpful to have that other perspective to uncover some of those things, and it can be very beneficial. It's not much money when you start thinking about a $1, $2, $3, $4 million accident to pay $5,000 or $10,000 to have a specialist come in and just give a review, a peer review, and try to help find any little nuggets in there that might be an issue, might be a problem. So very, very good point, Jim, and I appreciate that contribution. That's very, very valuable.
Yeah, thanks, Jim, as well. We have a couple more questions we'll do, and I do want to take that opportunity. I hate doing plugs. These are certainly educational opportunities for everybody, but we also, what I was mentioning is we do that quite a bit. We in our field services team, we conduct a lot of critical lift plan reviews, and it's really for internal teams, right, Mike? We do lift plans reviews without contractors involved. We also will help conduct lift director services. So that's when we're hired by an employer that's just handling it all in-house, just to have another set of eyes. We have a couple guys on our team that have really experienced in this and that. So if anyone is ever concerned or it's almost like if you don't have, it's not about 100% confidence, I don't think, about your internal team. It's about just assuring yourself that you have another set of eyes on it, like you said.
Yeah.
So I'll turn it back over to you. There's a good question here. During list planning, if I cannot find required info in LHE instruction, meaning that if something's prohibited or allowed, can I still proceed with lifting if I can prove the safety of the method or my method statement?
Okay, and restate that, Zach. And let me get my head around that really quick. So restate that, please.
Yeah, and it was typed out a little interestingly, but if I can't find the required info on the load handling equipment, meaning that they're not finding that the equipment's prohibited or allowed for something, can they still proceed with the lift as long as they can prove the safety of the method or the method statement?
I'm going to give two-part answer to that. The first response is no, don't go forward, and the reason is we need to exhaust the inquiry to the LHE manufacturer that they either allow or prohibit. We need to satisfy that and get it in writing. And so until that's accomplished, we need to stop and get that determination made. So the LHE manufacturer, if we want to put a load up on top of a gantry system and roll it potentially up some incline or whatever, it's way out of normal bounds for the use of that equipment. And but the first thing that the planner, lift director, lift planner want to do is get the information and get that from and do not proceed assuming I can do this on my own. We need to fully exhaust our investigation with the LHE manufacturer and get it in writing that they allow it or they prohibit it one way or the other. And by allowing it, they'll give us the instruction guidelines, restrictions, limitations, all those things to go with it. And the second part of that answer, if the decision is to go forward, then I just have to really be forewarning here that this is, if the decision is to go forward, that that equipment leaser or the party they are accepting all risk related to that work and to that activity, and that is that I would want them to make sure that they're letting their upper management, their president, their CEO, their board of directors, and their insurance carrier understand we have a big gray area here, but we think we can do this with this equipment, and everybody needs to sign off on it because they're putting that entire organization at risk, if not personnel, equipment, property, production, capacity, everything. So if they opt to go forward, they really should be appreciating, I'm putting this whole thing on the line here, and we're accepting, and that may be the case. You may have some very, very strange lifting activities. There's no prohibition, there's no allowances, and the manufacturer won't give you either way. And just understand, you really need to you become almost equivalent to the LHE manufacturer and engineering group to decide, can I do this or not do this with this type of load handling equipment? And in so doing, we are accepting all risk. So it's a very delicate dance, and it's very serious to help, to make that call. And what we definitely want to do first is make sure that we chase that bunny down the trail all the way through, that the LHE manufacturer is either all in or all out. And if the prohibition's there and we go ahead and go forward even against a prohibition, we pretty much, that it would be willful negligence, I think in a lot of circles. And I think that would be that could be cause for some major pushback if there is an incident, and people could be looking at some very serious issues with OSHA and with even some criminal activities if we're going directly against a prohibition or prohibited activity by a manufacturer. So it's really thin ice to go. You definitely want to go after the manufacturer first and get their entire buy-in if at all possible. That's very much the first line of action. Good question. Very good question.
Okay. Thank you. That's well, I got to say too, Mike, we're about 10 minutes over our hour mark, so we probably should wrap it up. We really appreciate everyone joining in today. I hope you learned something, and we'll let you know the presentation will be on our website. You'll find on the iti.com/showcase, you'll find where you can download all past presentation files as well as watch the recordings. So feel free to check them out there. And Mike, I'll give you the last word, but thank you everybody for joining.
Well, I hope everybody has a great summer and get the best use and the most time with your families, and enjoy the summer break wherever you're at, and enjoy your kids and enjoy your spouse, and just have a super summer, and look forward to continuing to have you join us with future programs in the next 2, 3, 4 months. We got some exciting presentations coming up by our own staff and others, and I just wish you very well, and make sure that always rig it right. You know, that's our company logo, and just make sure that we're taking the right steps to make the right moves and keeping everybody safe. So have a great summer, and we'll talk to you soon. Thanks.